Graphing linear inequalities. A linear inequality has an inequality symbol such as less than, greater than, less than or equal to, or greater than or equal to. Typically, the solution for a linear inequality is indicated by shading the region of the coordinate system where the ordered pairs satisfy the linear inequality. But in M115, the unshaded side is actually indicating the solution of the linear inequality. Graphing the inequality involves graphing the line, determining if the line should be solid or dashed, and testing one of the two sides of the line with a test point to determine which side of the line to shade, and shading the region where there are no solutions. The line you draw for the inequality is called a boundary line. This line will either be solid or dashed. A solid line indicates that the ordered pairs on the line satisfy the inequality and make a true statement. A solid line is used with less than or equal to or greater than or equal to. A dashed line indicates that the ordered pairs on the line do not satisfy the inequality. A dashed line is used with less thans and greater thans. Essentially, if there is an equals piece under the less than or greater than, then use a solid line. Let's take a look at an example. The example says, graph the inequality 3x minus 5y is less than 15. So first thing I need to do is graph the line. And when I graph the line, I notice that this is in standard form. We have 3x minus 5y equals 15. In standard form, it's easiest to find the x and y intercepts. And in this case, the x-intercept is 5, 0, and the y-intercept is 0, negative 3. So I began by plotting the x-intercept at 5, 0, and the y-intercept at 0, negative 3. I know I already have the dashed line on here, and just makes it for ease. Typically, you would have those 2 points to plot. Then I would draw a dashed line through these 2 points, and I would draw a dashed line because we have a less than in the original problem, not a less than or equal to. So then I would put my dashed line in on those 2 points. Now I need to decide what side of that line I'm going to shade, because remember the line separates us from where the true answers are and where the false answers are. Now I need to select a test point. A test point is any ordered pair that the graphed line does not pass through. I tend to like to use the test point 0, 0 for the reason that it's easy arithmetic. So I put 0 in where the variable x is, I put 0 in where the variable y is, and simplify. I get the statement 0 is less than 15. This is true. This tells me to shade to the right and below the line. That might seem kind of weird, but in this class and in the computer system, on the side that is true, our test point was true over here where 0, 0 was. We want to keep that area blank or white. And what we do is we shade the false area. So all the ordered pairs to the right and below this line are going to give us false statements in the inequality. So I would shade that area. Now the white side of the line shows all of the ordered pairs that satisfy the inequality. For example, if I took the ordered pair 1, 1, 1, 1 is right there, and test it in the inequality, it should come out true. 3 times 1 minus 5 times 1 is less than 15. I get 3 minus 5 is less than 15, so negative 2 is less than 15. That's true. And that's great because all of the points over on this white section should be true in the inequality.